Alright, so before we finish off this chapter, I wanted to introduce you to some software tools that are available. And since this is an important chapter in mathematics, this has a lot of applications in physics, in chemistry, in material science, a lot of places where you need to solve physical systems which involve simultaneous linear equations in n unknowns, where n can be a really large number. And so you have all these huge matrices to work with, and pretty soon, as you may have realized, you cannot work on them manually. So there are these software packages, and I'll talk about two of these software applications and why I personally like them, and you can also check them out. So let's just divide this up into two parts. So on this side, we'll talk about Matlab. And Matlab is a very special one for me personally. This stands for matrix, and this stands for laboratory. And on this side, I'll talk about a package called Wolfram Alpha. Now, Wolfram Alpha doesn't stand for anything, it's a name basically, but it's a derivative of a desktop package called Mathematica. Now, what's the similarity and difference between these packages? Well, to start off, both of these packages can be used to calculate values of determinants and matrices, and they have certain advantages and disadvantages. So if you're starting off with Matlab, the biggest advantage is it's a desktop package. So it's a program that you need to buy, and you need to install that software on your computer. But it's full featured, and it is extremely fast. It's been optimized for desktop, and it can handle very large data sets. So how big of a matrix can it handle? It's basically limited by the amount of RAM you have on your computer. But the disadvantage of this package is obviously you need to pay for a license, and it can get expensive unless you have institutional access to this software package. Having said that, it is a very useful and fast package. Now, Wolfram Alpha, the biggest advantage is it's online and it's free. So just go to wolframalpha.com and you can play around with some of the methods I'm describing, and the links are in the description below, so check out our description for this set of lectures. The disadvantage is it's sometimes slow, so it takes time to process and interpret what commands you're giving it, and the output is slow, and it does not scale very well. So you can't think about solving a set of 1,000 by 1,000 set of equations unless you have the desktop Mathematica package, which can also handle it. So I just wanted to give you a quick example of how things work, and they work a bit differently in these two packages. So in Matlab, for example, it's a command line interface, and let's say you want to input a matrix. The way to do that is on the command line you type A equals, in square brackets, 1, 7, minus 3, semicolon, 0, 25, 1, semicolon, and 3, minus 6, 2, and that's it. And you hit enter, and the output will appear as A equals, and on the next line you will see this matrix. So 1, 7, minus 3, 0, 25, 1, 3, minus 6, 2. That's it. It'll give you a rectangular array representation, no fancy square brackets or anything like we do when we write it manually, but the software has understood what you have written, and basically it's now taking this as a matrix representation. So how are elements separated? If elements are in the same row, they're basically separated by a white space, and then to go to the next row its separation by a single step. And the full matrix is enclosed in just these square brackets. Well, if you want to input a matrix in Wolfram Alpha, it works a bit differently. Wolfram Alpha will give you a search box that's kind of like a Google search box, except this is a mathematical computation package. And here everything needs to be in braces. So the full matrix needs to be enclosed in these braces, and every row of the matrix also needs to be in braces. And every element is separated by a comma. So it's a bit more clunky compared to how easy it is to input a matrix in Matlab. But you'll see some neat things come out of this. So this is, I'm putting in the input in Wolfram Alpha. So 0, 25, 1, and 3, minus 6, 2. Okay, you put this in the search box in Wolfram Alpha and hit enter, and you will see some interesting outputs. So this is what Wolfram Alpha gave me when I tried this out. First of all, it was able to recognize and understand, or the machine could parse your input, and it gave this input A equals, in nice fancy brackets, it gave it in this form. So 1, 7, minus 3, 0, 25, 1, 3, minus 6, 2. Now the fun begins. So when you put this into Matlab, it just spit out whatever you had input as a matrix, and that's it. But Wolfram Alpha kind of it read my mind, and it knows that the next thing that I'm going to ask it to do is to calculate the value of the determinant and help me find the inverse of this matrix. So even before you put in that, just by entering this one line in the search box, it gives you determinant equals 302 and inverse as 1 over 302 times 56, 4, 82, 3, 11, minus 1, minus 75, 27, 25. Isn't this beautiful? It's like one step ahead of what I am thinking of doing on this platform. Now guys, please, those who are listening to me, please don't use this as a method to cheat through your exercises. It's a great way to double check your calculations after you have worked through them, but not as a shortcut to doing the practice examples yourselves. And then, well, can Matlab handle it? Yes, it can. Clearly it can handle this, but you have to give it a special command. So again, input, you write it as determinant of A and press enter. The output will be answer equals 302. Then next time let's say you want to find out the inverse, you input inv of A. So these are special commands which Matlab can recognize. So you cannot write A minus 1, for example, at the command line. You have to follow the syntax, and if you write inverse of A, Matlab handles it a bit differently. Wolfram Alpha and Mathematica in general is a symbolic instruction package, so that's why it gives you in this form. And if you remember from our past session, this was exactly the system of equations that we were trying to solve, and we found this inverse manually. And this looks a lot like the manual calculation that we were doing, because this is a symbolic instruction package. Matlab, on the other hand, is more a numerical package. So when you put this input, you'll get the output as again, answer equals something like 0.2 1854. So it will give you a long decimal form of the answer, which isn't necessarily bad or wrong. It's just harder to understand where this came from, and you will see that if you actually do this multiplication, it works out to be exactly the same thing, but it truncates up to 4 decimal places, which is the normal value of the floating point operator used in Matlab. And then for doing ordinary operations in Matlab, the simple commands are A star B for matrix multiplication, or A plus or minus B for addition or subtraction of 2 matrices, whereas in Mathematica works slightly differently. It would be A dot B for multiplication and A plus or minus B for addition. And check out the links in the description below. There are more links to worked out examples using both these packages. Again, this is not a substitute for doing it yourself. Make sure you practice your examples. At the end of your exercise, if you